Hello, everybody, and welcome to probably the most important video in Unit 11. This sets the tone for the rest of the unit. There are some vocab words in here that you need to understand. If you don't understand them here, the whole unit will become way more challenging. I cannot stress this enough here. So I'm going to be inserting a lot of questions just to make sure you understand what's going on here. So please, if you're not going to, it's a little bit of a long video, but you've got to stick with it, especially here at the beginning. So a prism. What is a prism? A prism is a polyhedron with two congruent parallel faces. So they are parallel to each other. Okay. The parallel faces are called the bases. The bases are not always on the bottom. The other faces, everything else, are called lateral bases. Lateral faces. Okay. So the parallel faces are the bases. So you can kind of see the picture down below. The two faces that are parallel each other are the two hexagons. Okay. They're not on the bottom. They're in the front and the back. The lateral faces are all the rectangles that connect them. Okay, so I'm going to get to that again in a little bit, but I just wanted to make sure you see those words in use. All right, the altitude of a prism is a perpendicular segment joining the bases. And the height of a prism, and I'm underlining of a prism, is the length of the altitude. So the distance from one base to the other is the height of the prism. Okay, so I'm going to quickly go to a website that I pulled up, share it with you here. Okay, in this one, what is the height of the prism? Okay, a lot of people are going to put 4. It is not 4. The height of this prism is actually the 9. It connects the two trapezoid bases. Right? So the segment connecting those two is the height. You've got to understand that one. Okay. I also have a bunch of people who have a hard time with that. So make sure you catch what I'm saying here. All right. So back to the one we had kind of already talked about here, this hexagonal prism. Yes, that's what it's called. It's a hexagonal prism because what shape is the base? It is a hexagon. What shape are the lateral faces? I already said this. The lateral faces are the faces that connect the bases. Those are rectangles. What is the height of this prism? And that is the 10 centimeters. All right. So what we're doing in this lesson, the next lesson, and then 4 and 5 is finding surface area. So the first four lessons minus number 1 are surface area. And there's a plural, surface areas, because there's 2 types. But anyway, what is surface area? It's the area of the visible surfaces. It's not how much is inside, it's how much is on the outside. Think of wrapping a box with wrapping paper at Christmas. Okay, that's what you should envision when you're thinking surface area. All right, there are 2 types of surface areas. Like I said, the sum of the areas of the lateral faces only is called, naturally, the lateral area. You will see me write this a lot, LA, for lateral area. The sum of the areas of the lateral faces and the bases, so basically everything, is called the surface area. Now that can get a little confusing because a lateral area is a type of surface area. When I say surface area, am I talking about lateral area or surface area? And we'll talk about that on the last problem with these notes. Okay. In the hexagonal prism above, to find the lateral area, you would find the area of the 6 rectangles, or the 6 rectangular lateral faces. To find the surface area, you would use the lateral area, which is the 6 rectangular faces, and add the area of the 2 hexagons, or the 2 bases. So you can see, hopefully, where the area unit 9, is going to come into play. All right, so now I'm going to develop the idea of lateral area. So I started you out with a box. Or it's not a cube, it's a rectangular prism. And we actually could use the front and back as bases, the top and bottom as bases, or the left and right as bases. It could be any of them because they're all parallel to each other. But I'm going to set the ones that are marked there in blue X's as the bases. Okay, so the bases are the left and the right. What is the perimeter of my base? Well, I'm going to add up the sides of that small rectangle. So 2 plus 4 plus 2 plus 4. So it's going to give me 12. The height connects the 2 blue X's, so it's 7. Now my directions were to draw a net and label it. So I'm going to do it the kind of the same way I did with lesson 1. I'm going to cut it with the bottom part here. I'm going to let the front fall down. So the front is a smaller rectangle, even though it doesn't really look like it, because it's 7 by, the bottom is 7 by 4. The next one's 7 by 2. And then I'm going to go and lay the backside falls down. And that's also 7 by 2. And then the top is at the back. Again, you could do it a different way, but I'm going to go with that. And then the 2 bases, the 2 things marked with X's, I'm going to have them just fall to the right and to the left of the bottom. So that's a 4, and that's a 2. And that's a 4, and that's a 2. So these, just to make it clear, those are my 2 bases. Now I'm going to switch colors, and I'm going to, it says, look at the big rectangle that makes up the middle of your net. And I know my drawing is not great, but the middle of my net is a big red rectangle. What is the length of that rectangle, the vertical length there? Well, it's 4 plus 2 plus 4 plus 2. So 4 plus 2 is 6, plus 4 is 10, plus 2 is 12. So the length is 12. What's the width? So the horizontal distance is 7. Hopefully you've seen those numbers before. What is the area of that rectangle? Well, it's just 12 times 7, so 84. And I think it was, centimeters squared. The area of this rectangle was made by the bottom, front, top, and back. If you look back at the polyhedron, those were the faces that were not crossed out. They were the non-bases, or it was that was the area of all the faces except for the bases. What does that mean it is? Well, that's your lateral area. Okay, so why am I showing you all that? Well, the perimeter of the base times the height gave me the area of the lateral faces. Does that work every time? It actually does. Okay. So the lateral area of any prism. Now, the next lesson we're going to go over pyramids. Or actually, the next one's going to be cylinders, but then the one after that's going to be pyramids. It's going to change for that. Okay, and I'll tell you where that comes from when we get to it. But for any prism, the lateral area is found by multiplying, or the product of, the perimeter of the base and the height of the prism. So the formula, lateral area equals PH. Okay. The surface area is found by adding the areas of the 2 bases. So the formula for surface area here is lateral area plus the 2 bases. Okay, now another way you might see that written is surface area equals PH plus 2B. Now that B, that big capital B, and it is important that you see that it's capital, that represents the area of one base. That's why it's 2b, because there's two bases in a prism. Now, I can't give you a formula for b because that depends on the shape that your base is. On the front, we had a hexagon as a base at the very top. I showed you a picture on that website of a trapezoid as a base. I have on number 1 right below here, a triangle as a base. Okay. The shape is going to change, which means the formula is going to change. You've got to keep track of that, which is why Unit 9 was so important. Okay. So let's go ahead and do the first couple problems. Find the lateral area and surface area of each prism. Now, I'm going to recommend that you do this first. Identify the base and give the shape of the base. You might even want to write it down. So as you look at this, the two things that are parallel to each other are the two right triangles. All right. So the lateral area, I'll do that up here, equals pH, where P is the perimeter of the base and H is the height of the prism. Now, don't get mixed up here. The height of the prism is different than the height of the triangle. The triangle has a height of 3 feet. The height of the prism, though, is 8 feet. We have that already. The perimeter, we do not. How am I going to get the perimeter of this base when I only have 2 sides? I've got 3 and I've got 4. Well, I can do the Pythagorean theorem to figure out the last one. So 3 squared plus 4 squared equals x squared, where x is right here. Save us some time, x equals 5. So that's 5. Now, what do I do with those numbers? Well, I'm finding the perimeter, so I add them up. 3 plus 4 plus 5 is 12. Now it's as simple as multiplying them together. So I'm going to jump down here, space. I'm just going to do 12 times 8. So the lateral area is, what, 96 feet squared. Okay. The surface area is the lateral area, which we just found. So we know it's 96 plus 2 times the base. And this is what I will do. You'll see me do this a lot. So we've already found the lateral area. No need to find it again. We know that there's 2 bases, and they're going to have congruent areas. So now we need to actually find the areas of the big bases. So this is where I'm going to take my time, and I'm going to identify the shape. So the base is a right triangle. The formula for a right triangle is 1/2 base times height. So B equals 4. Again, I'm going to use my 2-dimensional shape here. The base is 4. The height of that triangle is 3. It's not 8. This H is different than this H. Okay, that's a tricky part of this. I get that. So 1/2, 4 times 3. 4 times 3 is 12. Half of that is 6. So big B equals 6. And I'm going to take that and I'm going to plug it in. Now, some of you are going to like, oh, could I just cancel the 1/2 with the 2 since I know I'm multiplying by 2? Okay, be careful of that. Because sometimes it'll get canceled, sometimes it won't. You don't want to look for shortcuts if they don't always apply. So I'm going to tell you that canceling that 2 and that 1/2 does not always apply. So I wouldn't get used to doing that. I would just find the area of the base, plug it in, and then just simplify. 2 times 6 is 12. 96 plus 12 is 108. So the surface area, if I add in the bases, the area of the bases, gives me a surface area of 108. All right, the next one's going to be a little trickier because the shape is a hexagon, and it's a regular hexagon, and that's important. Without it being regular, it gets a little challenging. It actually gets to be impossible. But the lateral area first is pH, perimeter of the base, and the height. The height is 10. The perimeter of the base, well, I know it's regular, so the 4 is all the sides. So 6 times 4, 24. This is pretty easy. So the lateral area is just 24 times 10, or 240 centimeters squared. Now, This is where it gets challenging. Surface area is the lateral area, so 240, plus 2 of the bases. Now, the base is a regular hexagon, which has the formula 1/2 AP. Might bring back some nightmares for some of you. Good news is this P is the same as this P. So I already know the perimeter is 24. Now I just need to find the apothem. And if you remember, drew my triangle. Perimeter was 24, which means a side length is 4, which I already knew that. But this is half a side length down here, so this is 2. Need to find that angle. That's 360 divided by 6, which is 60, divided by 2. So this is a 30-degree angle. Gives me my special right triangle. 2 is my short leg. My apothem, by the way, I'm going to draw what's going on in this. That's 2. My apothem is 2 radical 3. So now I'm going to go down here, and I'm going to multiply those together. So 1/2, 2 radical 3, and 24. So 1/2 of 2 is 1. 1 times 24 is 24 radical 3. That's one of the bases. 1 big B. I'm going to put that in here. So 24 radical 3 is going to go in here. Okay. And then I'm going to multiply the 2 times the 24, and my surface area is 240 plus 48 radical 3, and that's in simplest radical form. You could take that and type it in your calculator to get a decimal, depending on what it's asking you. So you should know how to do that by now. But all right. Please, 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 if you've lost attention at this point, come back to me now. All right. An above ground pool is in the shape of a regular octagonal prism. So you've got yourself an octagon. And you got your pool. Okay. You can hopefully picture, this is kind of, I'm looking down at it right now. The pool is 5 feet off the ground. Okay. And each side of the pool is 8 feet long. So 8 feet long. Okay. How much material is needed to make the walls of the pool? Well, the walls of the pool are going to be the connectors from the top of the pool to the bottom of the pool. So if you look at that, that's going to be a bunch of rectangles. It does not include the bottom. It does not include the top, which means I'm finding the lateral area. You have to interpret that. The walls of the pool interpreted means I'm finding the lateral area. I'm not finding the area of the top. I'm not finding the area of the bottom. The walls don't go on the top or the bottom. Okay, so the lateral area here is the perimeter of the base times the height, where P is 8 times 8, so 64. And the height is how high off the ground it is, because the ground is one base, and it's 5 feet off the ground, so it's how tall it is. So the height is 5. So then 64 times 5 gives me 320 square feet. Is how much material is needed to make the walls. Okay, even trickier maybe for some of you. What is the area of the lining on the inside of the pool? Well, where does the lining on the inside of a pool go? Well, it goes along the walls, but it also goes along the ground. Does it go along the top? Now, what I'm about to do is I'm going to show you what the surface area formula is for this problem. It is the lateral area, the walls, plus 1 base. Now you might be like, where's that going to be on my formula sheet? It's not going to be. You're going to have to reason through it. The big B, in this case, I'm not covering the top with lining. If I was covering the top with lining, it wouldn't be a pool. You couldn't swim in it. You're covering the bottom and the walls. You're only covering 1 base. You have to use your common sense here to come up with the formulas. All right. So the lateral area we already found, that was 320. And now I just have to go find the area of one base. Kind of already have it drawn here. Again, we're doing the 1/2 AP. It's a regular hexagon. I've got the perimeter already. It's 64. One side is 8, so half a side is 4. Now that side is no longer a 30, 60, 90. This is a 22.5 degree angle. So the tangent of 22.5 equals 4 over A. So then hopefully by now you know how to solve that. That's A equals 4 divided by tan 22.5. So my big B is 1/2 4 over tan 22.5 times 64. I'm going to multiply the tops. I'm going to change colors again. 1 times 4 times 64 is 256. Divided by 2 tan 22.5. And then 256 divided by 2 is 128. So 128 divided by the tangent of 22.5. So that's 309.0. So plus 309.0. So just 309. Okay, so add that to 320 to get the lining of the pool. So 629.0 feet squared. And again, I know it's a long video, but hopefully you understood the vocab and what these things mean and how they're represented. We're moving on to cylinders tomorrow, which are going to have different formulas, but in reality, they are the same formulas.